internal rate of return, IRR. It's actually very similar to NPV. We use the same formula, we just rearrange it a little bit. We don't actually work with the formula. The computer helps you quite a lot. The computer just basically does the job for you. You just need to understand the question and know what's required of you. In the modern world, in the 21st century, you don't even need to memorize all of these formulas. You need to be able to use your brain to understand what's asked of you. You don't need to memorize all of these tricky formulas. You can always access them on the internet, but you really need to understand what you're talking about. So with that in mind, let's have an understanding of this formula for IRR so that we know what it's about, even though you're not going to use this formula by hand. Okay, so for NPV, we basically just discount all the future cash flows according to the required rate of return appropriate for the level of risk. If the risk is higher with a given project, we just apply a higher required rate of return, because for you to invest into a more risky investment, you'd only invest if the return is greater. So your requirement for that return, required rate of return, is greater. Going back to NPV, we discount all the future cash flows at a given required rate of return and find NPV. If it's positive, the project is going to make you money, so you invest. For IRR, we just do the opposite. Make NPV 0 and find what's the return inside that project. So internal rate of return. Then compare this internal rate of return with the required rate of return. If IRR is bigger, then invest, otherwise don't. So it really does show you the same picture, but from a different perspective. It's just a different side of the same coin. Calculating IRR, very easy process. Open Excel file, hit equals, type IRR, open the brackets, you get all the hints. So let's have an example. Very easy. Years, cash flows, let's say, and let's say we have our required rate of return 0, 1, 2, 3, and whatever it is. Say you are building some factory, it's going to last you 12 years. It's going to take you 120 million first to build the factory, and after that it's going to generate some money, starting with some small money, 1 million, 2 or 3 million, and after that perhaps more millions, say anywhere between 5 and 10, like that. And let's say the required rate of return, let's say it's a relatively low risk investment, it's a local investment, you're going to control everything. Let's say your required rate of return is only 7%. Let's calculate IRR here and answer whether we want to accept or reject the project. Equals IRR, open the brackets, enter the numbers, close the brackets, bam. Okay, so these numbers are too small. We don't even get 120 million back, yes? Okay, let's change the original investment, say down to 55 million. IRR is 3%. I don't think it's actually 3%. What are the chances? It's perhaps 3 point something. So remember to give me the details, otherwise the answers are not going to be correct on the exam. 3.18 is not equal to 3. So if you enter 3 as your answer, that'll be wrong. So do we accept the project here or do we reject the project? Remember, we compare with the requirement to see if we accept or reject the project. The project returns us, the project gives us, so the internal return is just over 3%. But for this level of risk, our requirement is at least 7%. So we reject. Let's write it down. Because IRR is less than the required rate of return. Okay, a bit confusing here. It's IRR and RRR. I'll use the triple R for the required rate of return. So we got that. Now let's try to calculate NPV, just to see whether these two criteria will tell us the same thing about the project, whether we accept it or reject it. So equals NPV, open the brackets, very easy. The rate, comma, values starting from the first cash flow, not the zeros cash flow. So that's something that is easy to forget, actually. And another thing that's easy to forget is to add the original cost by hand. Enter. And the computer thinks it's in percentages, perhaps because we already have some percentages here. So let me cancel that. We just can go to, if you have a similar problem on your exam, you can just right click, go to Format Cells, and go to General, click OK. So this project loses 13 million. But anyway, even a little bit of a loss, even just $10 loss, as long as it's negative, even if it's zero, why would we invest if we make $0? Okay. So this is our NPV, and again, reject because NPV is less than 0 or equal, or even like this, less or equal, equal or less than 0. Okay, so what's the connection between them two? Well, if I change this interest rate, if I decrease this interest rate, NPV is going to improve. And at one point, NPV will turn positive, allowing me to accept the project. Same with internal rate of return. If I reduce the required rate of return, at one point it will become lower than the internal rate of return, allowing me to accept the project. So let's put that on a chart. Let's put it on a chart. Let's have rate here, required rate of return, okay, internal rate of return, both rates here, and let's have NPV on the vertical axis. Right now NPV is negative when the required rate of return is 7. Actually, let's put some numbers there so you know where we are. This is 0. That's 7, and this is rates on the x-axis. So when the rate is 7, NPV is actually negative. So NPV is somewhere around here into negative when the rates are 7. But if I keep decreasing the rates, if I keep going to the left, NPV is going to grow, right? NPV is going to improve, coming to some highest number whenever the rate is 0. Actually, I can tell you exactly how much is the NPV when the rate is 0. If the rate is 0, today's dollars are the same as tomorrow's dollars. Then I can just have a sum over here giving me NPV equal to 15 million. So this will actually be 15 million on NPV. Okay, that's if the rates are 0. So that's what's called NPV profile. NPV profile. Okay, which is the relationship between NPV and required rate of return. So this is called NPV profile. Okay, of course it's a downward slope line. As rates increase, NPV drops. And when we calculate NPV, we choose a required rate of return. Let's change this number here. Let's choose 2% here, or 2.2% for example. Let's show some details, 2.2%. NPV, as you see, has increased to 4 million. So what we do when we calculate NPV is we just choose the required rate of return, and the computer finds the value for NPV for us. In our case right now, it's 4 million, right? So that's calculating NPV. Of course, if we choose a higher rate of return, NPV is going to be lower. As with 7, NPV is going to be negative. But with IRR, we basically actually, we are looking at the same NPV profile. And what we're doing is we make NPV equal to 0. As you see for IRR, we actually make NPV equal to 0. Instead of this side, we have 0 here, and find the appropriate return to make NPV 0. Here we find where NPV is equal to 0. NPV is 0 at this horizontal line. So NPV is 0 over here at the rate, at the internal rate of return. I mean, my profile, of course, is not really correct. It probably should be something like that, because it's 0 at 3.18. Internal rate of return is 3.18. So if I were to draw this NPV profile correctly, it would look something more like that. 3.18, maybe something like that. NPV is at 0 when the rate is 3.18. So move this here. So that's the main idea of internal rate of return. There it is. Let's zoom in a little so you can see calculations of IRR. Just hit equals, type IRR, open the brackets, and put all the numbers there from starting from the very original cash flow, which is let's say the costs, up to everything. Hit enter. That's all. Very, very easy. But sometimes, even though IRR and NPV are kind of different sides of the same coin, sometimes they can conflict a little bit. They can conflict a little bit. They don't conflict on whether they should accept or reject the project, but NPV versus IRR in different size projects. That's for ranking of projects. So NPV and IRR, they don't conflict in terms of accepting or rejecting the project. If NPV says reject, IRR is going to say reject as well, and vice versa. But if I'm trying to rank the projects, let's say I have 2 or 3 places for my factory: Japan, Taiwan, Vietnam, and they're all pretty good projects. And I'm trying to choose the best because I don't have money for all 3 projects. Then there is a potential for some conflict between NPV and IRR. They don't have to conflict, but they may conflict. So you really need to understand this difference, right? Let's say project A, and let's say project B. Years, cash flows, maybe like that. Maybe we could even separate them too. Okay, say an 8-year project, minus $1,000, let's say, giving us 220, 250, 300, and 300. And negative 1,800,000, and giving us 360,000 back every year, for example, right? Let's calculate IRR for both of these projects. IRR equals, so equals IRR, open the brackets, and just enter the numbers. Bam. Woohoo! That sounds great. That's like 21.6%. Great, great, great. Let's find the IRR for this project. Equals IRR, open the brackets, put the numbers there. It's only 12%, even less. Ha ha ha. So bad. Let's say our required rate of return, for example, just to make it simple, for both of the projects, required rate of return is only like, let's say, 5%. So both projects are acceptable, but I can't make both. Let's say, for whatever reason, I can't make both. I don't have time to implement both projects. Which one should I choose? According to IRR, I should choose project A because I'm going to make 22%, nearly 22% return. Sounds much better than under 12% return. But let's have a look at NPV, what NPV says. NPV equals NPV. The rates requirement is 5%, we said, right? 0.05, comma. All the values starting from year 1. There it is. So with project A, I'm gonna earn over $800. How about project B? Equals NPV, open the brackets, the rate, the positive values, 0.05, comma, close the brackets, and add the original cash flow by hand. Okay, that actually looks better, you see? In the project B, what I earn is $500,000. With project A, what I earn is $800. $800, and just $500,000. I think I prefer $500,000. But if you look at IRR, it's only 12% versus the IRR of 22% for project A. So the trick here is of course in the size of the project. It's much better to earn 12% of 1.8 million rather than earn 22%, oh my god, so much, of just $1,000. So sometimes the NPV and IRR, they can conflict on the ranking of the projects. Let's see, have we covered everything about IRR? So an example over here as well. We've already had a few examples. We have NPV profile. The IRR is finding the rate at which NPV is equal to 0. We've talked about that. Oh yes, let's have a few questions about the IRR. Okay, does it, for example, take into account the risk levels of the project? Here we do take into account the risk, because we compare the IRR with the required rate of return, and the required rate of return depends on the risk level. The advantages, it's very easy to understand. It basically shows me that the rates, the percentages, profitability that I'm earning on this project, that's all. Okay. And the good things is, yes, it does take into account all cash flows, it takes into account time value of money, and does look at some level of risk through the required rate of return as well. Okay. Of course, there are some disadvantages. Sometimes ranking the projects is conflicting with NPV. The main disadvantage here is sometimes it just doesn't work. It produces multiple answers. So that brings us to the next subtopic. Okay, when can IRR produce multiple answers so it doesn't really work, and what can we do about that? So this NPV profile is a straight line if the cash flow changes sign only once. Like this. Over here, cash flow changes sign only once, from negative to positive. After that, we just have positive numbers. Cash flow doesn't change sign at all. One change, everything is very easy. IRR works, NPV works, everything works. NPV profile is just a straight line. But when cash flow changes sign 2 times, something like that, for example, let's make some numbers bigger here because the positive cash flows are not enough. Something like that, let's say. The NPV profile is not a straight line. NPV profile is going to look like this. Okay, let's make this into 26. In this case, NPV profile is going to look like this. Because, so if rate is 0, meaning all the dollars are the same, future dollars and today's dollars, NPV is going to be negative, as you see, -1. If the rate is very, very high, very, very high, not 7%, 11%, 20%, 38%, whatever, then it means that very near dollars are important, everything else is just not important. We just almost don't count it. So very near dollars are important. Again, in that case, NPV, as you see, is negative, right? NPV is going to be negative with very high rates. NPV is only going to be positive if the rates are somewhere in the middle. The rates are high enough to make this future dollars are kind of not really important. That's where we have the cost. So this is not going to be an important cost. But it's not so high to make the middle dollars unimportant. So they are still bigger than the negative $10 cash flow at the beginning. So we have a positive NPV in total. So in this case, if we look at IRR, IRR is the point where NPV profile hits the x-axis. In this case, there are 2 points where NPV profile hits the x-axis. Then what is IRR? So this project is going to give me what return? This much return or this much return? The answer just doesn't make sense. But what's the percentage gain from this project? So the calculations are kind of like, where's the sense in this? In that case, IRR doesn't work. So what we're going to do is use another criteria, which is called modified internal rate of return, modified IRR. So let's have a look at an example of calculating modified internal rate of return, MIRR. Let's say we have this 12-year project starting with the original investment of 160, say, million, and perhaps this project has cleanup costs at the end of 30 million, and here are some numbers for the cash flow the project generates. The project is, of course, risky. Any investment is risky, so the required rate of return, reflecting the level of risk of this particular project, is, let's say, 7%. Now, what happens when do we calculate modified internal rate of return, MIRR? What happens is, what the computer does is, it brings all the negative numbers. We have two negative numbers here. It brings all the negative numbers in front to the beginning of this period, the period of the project. And it brings all the positive numbers back to the end of the project. So basically, if we bring the future cost to today, we'll have to discount that value and we'll have additional costs today perhaps. So you'll have to raise additional capital, which is financing. So the formula for modified internal rate of return also requires a financing rate, because perhaps there is some additional financing to make, right? And instead of taking the positive cash flows as they go every year, if the computer brings all of these cash flows back to the end of the project, it's like basically reinvesting these cash flows until the end of the project instead of putting them back into your pocket. So the modified internal rate of return formula also requires a reinvestment rate, right? So let's have those two. Let's say financing rate is 3.2%, just for example, it could be anything. And reinvestment rate is, let's say, 2.9%. So what's the formula for MIRR? Very easy. Hit equals and just type MIRR, open the brackets. You get all the hints, starting with all of the values, very easy, comma, finance rate. So let's just click here, another comma, reinvestment rate. That's all. Close the brackets, hit enter. Use this button for more details. It's actually 7.51%. In this case, it's greater than the required rate of return, so looks like we should accept the project according to the modified internal rate of return. So let's give it a name as well. MIRR is equal to 7.51%. Let's calculate NPV as well. Equals NPV, open the brackets. Our rate is 7%. That's the required rate of return. And the values starting from the first year rather than the year 0. Remember to add the original costs manually, and we do have positive number here, which is in percentages. Again, right click, format cell, and go into general. We have 68 million in positive NPV value, so we accept the project according to NPV as well. But sometimes modified internal rate of return would tell us that we should reject the project despite NPV being positive. So sometimes these two can conflict as well, because modified internal rate of return includes more details in addition to the required rate of return. So depending on what's the financing and reinvestment rate, the conclusion of calculating the MIRR might be different. So let's change these rates. Let's have the financing rate of, let's say, only 1%, and reinvestment rate, well, let's say only 1% as well. So all of these positive cash flows, instead of putting them into the pocket right now, we're going to reinvest them until the end of the project, but that reinvestment is a relatively low return. So perhaps that's not really going to generate much benefit. So according to the modified internal rate of return, all of this sort of procedure, financing the future costs now, and leaving all of the positive cash flows for later with a relatively low reinvestment rate and low financing rate, doesn't really give us much benefit. So modified internal rate of return is only 6.25%, less than the required rate of return. So although NPV is positive, a modified internal rate of return would suggest rejecting the project. But as I mentioned before, NPV is the most important criteria, as it shows the actual value in dollars that the company will generate from the project. So whenever NPV conflicts with any other investment criteria how we look at investments, how do we analyze investments, NPV always wins. So there you go. We've just reviewed IRR. We've looked at NPV profile and modified internal rate of return.